guys, welcome back to Rocket Gyan, my fellow space tubers, and today we are here back again to witness the Astra trying to launch their rocket 3.3 to space. And yes, if you are a frequent viewer of this channel, so you must be knowing that Astra has had a bit of a history in their launch business, but let's hope today is the day when they will successfully make to the orbit. And obviously they have previously made it to the orbit, but reliably is the thing which they are looking for. And welcome all to the stream. Hi Luca, welcome to the stream. Hi Jason, hi Mechanics. Well, aerial photography. Okay, if you have something you can do, share with us some samples. Mechanics will, and I can help. So we'll answer everything. How's the weather looking, Ken? Well, I'll tell you. You are here with me, and now I am actually much prepared with my preparation. So yes, I'll tell you. You will get to know about that. And yes, so let's just jump into it. But before that, let me just tell you that Astra tried this attempt of launching in previously also, I mean yesterday, and they had to scrub the launch because of the triggered lightning condition. Okay, it means the weather condition. So they are looking in for today, and for today they don't have a big launch window as they had previously yesterday. But the problem for today is that they don't have a backup launch window now. Okay, so if anything goes wrong or a weather constraint is there, they won't launch it. They will then launch it on some other day, because the launch window was for March 14th and 15th. So that, from I think that out of the way, now let's just jump into it. So Astra, what is an Astra? What is the Astra rocket company? First of all, guys, you can just see it. The patch is just so beautiful. I must say that this is the rocket. This is a bear, and I just have not downloaded, or you can say the patch for you to see. But if you get the chance to see, then this is a very beautiful patch which they have designed for this mission. Okay, anyways, so let's just jump into it. So this Astra is a small sat rocket company which will be launching today from Kodiak, Alaska, and it has also tried to launch from Florida for LV0008, but unfortunately that mission was not successful and had some issues, and we'll talk about those also stream today, so don't worry about that. Regarding the payload capacity, right now it's 50 kilograms, and it is bound to increase to 500 kilograms to 500 kilometer mid inclination orbit, and around 335 kg to sun synchronous orbit. So that's what they are aiming for. And guys, these figures are very, the payload to low earth orbit or payload to sun orbit are very much say, very much specific. I mean, this number which you are seeing, okay, sun synchronous orbit is good, but when people say that like this 630 kilograms to low earth orbit, this number is very, very specific, and it has, like, it should always have some star with it, because when you say like 500 kilograms to low earth orbit, what do you mean by that? Like, how much kilometer is the altitude? What is the perigee? Is it an eccentric orbit? Is it a circular orbit? What is the inclination? What is the other orbital parameters? We need to know that, then only we can define it. But like here, sun synchronous orbit is all right, because there the inclination, there okay, here you don't know the actual height, but we can assume around 500 kilometers or so. So yeah, this is one thing which I have noticed in many launch companies. So if you are planning to make some launch company in future, so please keep in mind that have an asterisk in front of this and just specify what you are talking about. Okay, like this graph has a very good meaning to it now when I say that. Okay, so let's have a look at the rocket itself now. So where is it? Yes, there you go. That's the Kodiak bear. That's great, Jason. I didn't know that. Okay, we'll see. No worries. So now the rocket. I know you have seen it many a times, but this is how we proceed with it, so that any other person who is new on this channel can get along with us. So this is a rocket 3.3 which they have said, and this rocket is powered by the 5 Delphin engines. So these 5 Delphin engines are very you can say unique in the sense that they are run by electric pump fed cycle, and I know Electron also has that cycle, but you know, electric pump fed is always a unique cycle to have. You won't be seeing this electric cycle in bigger rockets like Falcon 9, Starship. No, does not have work like that, because the battery capacity is very limited, and to run those turbo pumps you need very high capacity batteries, and obviously you don't have those for big rockets. So for smaller rocket it does make so much sense, because for electrical engines, right, which is powered by electric pump fed, the what should I say, the complexity of the engine drastically reduces, because here everything, the actuation means the gimbling of the engine, the speed of the turbo pump, and how the fuel is being supplied, everything can be controlled by a software, right? You can just have a software to control the rpm of the turbo pumps, and then the actuators to how the those gimbling would look like. But in bigger rockets that is done by mechanical actuators, mechanical, everything is mechanical, the fluids are going in the rocket, so hydraulics are working, so those things are very much, you know, mechanical thing, and that's why very complex. But for smaller rocket like this, we don't have space to spare and weight to spare, so those things, electric cycle does make so much sense. So these 5 Delphin engines basically produce around 145 kilonewtons of thrust. This is the total thrust which they produce, and runs on RP1 and locks as its fuel. And if you see the first stage itself looks like you know, very similar to the Starship rocket, and it is indeed you know, that's how it looks like, because it is how it that's how it's made also. So these are the, like in the Starship we can see the rings around the rocket, right? So this you can see here we also have the rings in this rocket too. And yes, this is some sort, the material is some sort of stainless steel, so yeah, that is the case. And talking about the second stage is powered by pressure fed ether engines, and you know, this is like a bit incomplete here, but you can see there will be an oxygen tank here, and then the, you know, the sorry, the um, RP1 tank here, and the oxidizer here, and then the normal pressure fed engine, which means just the tanks are pressure fed, which means the tanks are pressurized, and the valves are opened, and the fuels are mixed with the igniter, and it combusted. So that's how the pressure fed engines work. But there is also catch with the pressure fed engines, guys. Like if you think like, you know, we'll try to increase the pressure of the tanks, and you know, more we increase the pressure of the tanks, more performance we can get out of the engine. But to some extent that is true, but not far enough, because you know, there is some sweet spot which you hit. If you hit that, then the performance in fact decreases if you increase the pressure inside the tanks. Because then what happens is, when you increase the pressure inside the tanks, right, then you aren't able to, after a certain limit, you aren't able to control how much fuel is coming out of that tank. And sometimes you mess up the fuel to mixture ratio, or maybe some incomplete combustion is happening because more fuel is being supplied than it can be combusted. So those are the things which goes into the planning of those engine design and everything. But yeah, you get to know, get to see what I'm trying. Yeah. Okay, so yeah, that's pretty much about the rocket. Now let's have a look at the thing which we have to say. Okay, so yeah, this rocket is just 42 feet in height and can be transferred in a shipping container, standard shipping container, and which and it is evident from this photograph. So here you can see this is the scale. Also you can see here almost like, you know, a long, you can say a small car, 3 times this car, you can say that is the height of this rocket, and it can literally be transferred with this with the small truck. And yes, and that's why, you know, since it is an hilly area in Kodiak, Alaska, which means lots of mountains and whatnot are there, and because of those mountains there are very much, you know, those curvy roads out there, so you need to have some sort of way to transport them. And luckily they have made this rocket in such a way that it just does not matter to them for you know, the transportation does not matter to them as a problem to them basically. So yeah, this is how the rocket looks like. You put the rocket to scale. Okay, now let's have a look at the payload. So the payloads, the first payload which is going to space is from this Orsat company, or you can that would be much good to say, because this Orsat is the student funded set, not student funded but student made CubeSats. That's what they made, the CubeSats they make. And this is an open source organization, which means everything is available on the internet, you know, the specification of the satellites and how they made and all those things. So that's a very noble work they are doing, because when you are trying to make anything open source, that means that is available to free for all, and that's how you can make other students interested in satellite technology and whatnot, right? So talking about this Orsat, they actually have this 3 satellites basically, the Orsat 0 and Orsat 0.5. so today the Orsat 0 will be launching, and this is the flight heritage tester. That's what they call it, the flight heritage tester, which means they will be testing the specific satellite hardware, like everything is working as per the parameters, and you know, nothing burns up and all those things. And once they have that, then they will be making this Orsat satellite, which is funded by NASA CubeSat launch initiative, and in early 2022, that's what they say, but we'll have to see now what happens. It's not happening in early 2020 for sure, but it will be deployed into low Earth orbit from ISS, and it has 2 amazing missions, outreach program for Oregon, and a climate science mission. So this is what they will be doing with that. Talking about this Orsat 0, this is their flight heritage mission, which means they will be catching, you know, demonstrating the critical functionality of the Orsat system, including solar boards, battery card, onboard computer, engineering radio and telemetry system, and over the air, you know, OTA updates, software updates, antenna deployer, and more. So here you can see there are lots of cards in there. They basically, in this satellite, what they will be doing with this satellite, they will be testing all those things, right? The antenna deployment, the battery card, this is the part which should not catch fire, that's what they say. Obviously a star tracker card for you know, aligning in space. And then you can actually see, since it's an open source, so you can actually see what all cards they are carrying. They are like 7 cards. There you can see these, they are 7 cards, and each card has its own function. Like card 5 is a star tracker, and then onboard computer is on card 2, and yeah, so this is how they are trying to do. Okay, the next one is this one, the S4 crossover. This one is pretty interesting, because this is the only satellite which will not be, not, I won't say it's a satellite, but this is the only payload which won't be deployed from the Astra. And this will be you know, it's the goal of the S4 crossover is to obtain flight heritage testing for a prototype payload host platform. Hence, as the name suggests, payload host platform, which means that if you are having some experiment which you have to run in space and you don't want to make a satellite for it, then contact S4 crossover and you know, host your experiment in their platform, on their platform, and yeah, then you can run it in space. So they will be testing the basically all the hardware, particularly Globalstar transmitter, Iridium transceiver, as well as the space environmental instruments, like is it able to survive the harsh radiation environment. And yeah, so this is also a flight heritage mission. Okay. Okay, so there is also a third payload which is undisclosed, and let me just tell you, Astra is a very secretive organization. Since, the funding for making the Astra rocket was, funded by the Department of Defense. So there are certain parameters which they can't share, like thrust to weight ratio of the rocket, also like the combustion chamber pressure, and all those things are not out in the public. And the third payload is also undisclosed. So I am just saying that this is my speculation that obviously that the third payload must be from that Department of Defense, having some secretive technology testing or something like that. Okay, so that's it. Now if we look at their inclination, sorry, what orbit they are going, so they are going to sun synchronous orbit, 525 kilometers and 97.5-degree inclination. So they'll be launching from Kodiak, Alaska, which I have already told you. And yes, as I said, the launch window is 15th Tuesday, so they had like 2 days only. And so today is the last day. If they are unable to launch today, then it will be postponed to some later date, which will be announced then whenever it is possible, right? Okay, so talking about the mission timeline is pretty much standard. Since the ether engine does not have the restart capability, the second stage, so once the second stage ignites, it just goes on till the fuel depletion, and then the payload deployment happens. So we don't know whether, like, we know that one of the payload will be deployed, one other will not be deployed. Not so sure about the third one, so we'll have to wait and see. And yep, I've already discussed about this. Again I did that, right? Again I did that. Yes, thank you so much. Again I did that. I'm so much okay. Well, very well, good. This is the second time I did that. Wow. So I'm so mad at myself right now. I just can't tell you. No worries. I'll just so yeah, I was talking about this. This is scale I was talking about. You can see here the rocket is like just 43 feet long. So this small car, you can say 3 times this small car, and can be shipped. And I'm so sorry, guys. So sorry that I didn't change the screen, but yeah, I'm trying to cover it for you. So I was talking about this thing, the Orsat 0, which was the payload. Here you can see there are like 7 cards in here, the Orsat satellite, and they have the descriptions here. You can see that, right? So I'm so sorry, guys, that happened. Okay, so it's frustrating, but yeah, it won't happen from now next time. But yeah, so coming on to this S4 crossover, as I already said, this is again a payload hosting platform which they will be testing. And this is what they the inclination and the altitude looks like. The 14th of March and the 15th of March is the launch window. Inclination 97.5 and altitude 525 kilometer. And here I was talking about the mission timeline. You can see here upper stage ignition and the cutoff. No second in start one as such, like that. Okay. So also since the payload is not being deployed, the S4 crossover, so it will stay on the rocket, the second stage, in the orbit for weeks before it naturally decays and come back down. That is the thing. So yes, we need to discuss about what happened with the previous mission. The previous mission had some problem wherein it was not successful, and the reason for it not being successful, we all saw that the fairing did not open, and then the second stage started doubling. So the reason what they have given is the separation mechanism. there are 5 of them, were fired in an incorrect order, which resulted in an off nominal movement of the fairing that caused an electrical disconnection, which means the wiring and was done in incorrectly, which resulted in off nominal movement of the fairing, which means there are some things, the separation mechanism has some what should I say, pyros in there which fires, and they have to be fired in an specified orders, and because of this wiring problem they fired in an incorrect order, and because of the disconnection, due to the disconnection, the last separation mechanism never received its command to open, which prevented the fairing from separating completely before the upper stage ignition. That is one thing. The other thing which they got because of this was a software issue that prevented the upper stage engine from using its thrust vector control system, which allows the engine to alter how its thrust is directed, which means the thrust vector, which means the steering capability of the second stage, was also lost because of a software issue. And this software issue was also connected with the fairing one, which means there was something called a packet loss which happened, and this packet loss happened because there was some disconnection of the electrical system, and the fifth, you can say the fifth separation mechanism did not get the command, and since it did not got that command, so those that thing actually triggered many chain reactions, and because of that loss of command for the first, the fifth fairing separation mechanism, it resulted into a packet loss, which resulted on which actually caused the thrust vector control to not activate on the rocket. Yeah, that would be the word. So as I said, failures are always something which teaches you something, and this packet loss thing, I am pretty sure they wouldn't have identified if it wasn't for this failure, because this packet loss thing is very particular, and it happened just because of that pairing separation thing in which one of those pyros did not get the command. So this is a very particular thing which they identified in the software, that yes, their software has this packet loss exception, which they have not handled with a try catch if you are into software development. So yeah, that's what it is. So now let's move on to their, okay, to correct this, they have actually literally they had to remake the engineering diagram, do some correction in the engineering diagram to correct the fairing and the software issues. The software obviously has been updated. So talking about the weather, here you can see right now it's 31°F, which is pretty cold out there, and it's 9 a.m, so 38% cloud cover you can see, and the winds are 4 miles an hour. So things are looking good in this on this perspective, but the launch is scheduled at around 9:21 EDT. So we'll have to wait and see how that looks like, because the cloud cover actually just worsens as the time progresses. You can say 30%, 38 and 52, and you don't want cumulus cloud condition to violate the weather, as well as that triggered lightning condition. Obviously today the precipitation chances are pretty low, you can see only 2%, so the rain is not a problem today, but still cloudiness is still a problem. So we'll have to sit and see. We have not got the hey, thank you so much Nakajima Yosuke for 190. I am thank you so much, really appreciate it, man. Not only a naughty rocket, we now have a naughty RG. Yes, I did. Sorry for that. How I cannot stress enough to Astra staging. Always check your staging. Yes, indeed. We indeed thought that when it happened, the staging was incorrect, because the second stage ignited before the fairing got opened. But yeah, okay, one thing which I have to apologize for is that I have to make this confession, guys. Yesterday in the stream I said the Astra actually depends on Ukraine for the development of the first stage. That is not Astra. Very much sorry for that. That was Antares rocket launch. So Antares rocket, it has like Russian engines in it, and the first stage is developed by Ukraine. So really sorry for that. Astra does not depend on Ukraine for them, but yes, I do stand by that claim that we have many Russian investors in Astra, and now we have the live stream, so I'll switch over to that. Okay.
Water towers fly!
Okay.
Tango Delta nominal.
Yikes. You bet. Concur. We don't need any more of these.
Hello everyone and welcome back to live Astra launch coverage. You are looking at a live view of LV0009 out on the launch pad in Kodiak, Alaska. Astra is just under 30 minutes away from conducting today's launch attempt with the goal of delivering multiple payloads to orbit for Spaceflight Incorporated. My name is Thomas Burkhart, News Director for NASA Spaceflight, and I'm joined once again by Carolina Grossman, the Director of Product Management at Astra. Carolina, thank you so much for joining me again. How you doing?
Great, ready for another launch attempt today.
Me too. It should be a great day for launch. Thank you all so much for tuning into today's coverage. Again, Astra and NASA Spaceflight are partnering to bring you this broadcast, so thank you to Astra for helping make this happen. Over the course of today's broadcast, as usual, we'll be taking your questions, so if you have any questions about today's mission, please tag us at NASA Spaceflight in chat, and we'll try to get through as many of those as we can during today's coverage. This is the second day of the launch window. If you were here yesterday, you know that there was a weather violation causing the new launch target of today. Carolina, can you tell us a little bit about what the weather's looking like today and the status of today's launch attempt?
Sure, the team is proceeding through our countdown procedure, and all things are looking nominal. You can see from that middle section of LV0009, that frosty white color indicates that propellant has been loaded onto the vehicle, and the teams are not tracking any issues prior to launch.
And today's launch window is a 27-minute launch window, which is slightly shorter than yesterday. Can you tell us a little bit about the launch constraints that are defining today's window?
That's right. So this mission has a precise requirement for the local time of the descending node, LTDN. It's one of the parameters that can be used to define an orbit. And due to the specific requirements for this mission, we had a 29-minute window yesterday, and today it's 2 minutes shorter due to a COLA, or collision on launch avoidance, for a spacewalk happening on the ISS, on the International Space Station. So in order to keep our mission safe as well as the astronauts on the International Space Station, we have a 2 minute shorter window, a 27-minute window today.
Right now, that countdown clock, just under 27 minutes to go, is still targeting the opening of the window, which is still 9:22 a.m. Pacific time, or 16:22 UTC. And like Carolina said, no items being worked right now. Everything appears to be on track. As we start to get into some questions here, again, please tag us at NASA Spaceflight if you would like to ask a question. We'd like to take a look at the pre-launch static fire test, which was successfully completed last week.
Okay, so the static fire needs to be seen here now. Obviously, it looks amazing. Static fire are amazing, and kudos to their team. You can see it's like -7 degrees Celsius, and they just work hard. This weather, Alaska weather, is very hard. I'll say that.
10, 9, water on, 8, 7, 6, 5, 4. +7, shut down.
That was amazing.
Clean shutdown.
And we're starting to get some questions into chat, and we'll start off with this question. Insert genuine name, nice username there. Is there any payload on this mission, and if so, what type? So what are the payloads on board today's mission?
Sure, we have several payloads on our mission today, which is the Spaceflight Astra-1 mission. We are very pleased to announce our partnership with Spaceflight Incorporated, a launch services provider. And two of the payloads that we'll highlight are the NearSpace Launch S4 crossover payload, which is going to remain attached to Astra's second stage. It's a technology demonstration mission which will test a prototype payload host platform that can be used to test future payloads, and also has instrumentation for measuring radiation and plasma density in space. And so it is attached to the second stage, but operates completely independently and will operate for a few weeks following the launch. And the Portland State Aerospace Society's Orsat 0, which is a fully open source CubeSat satellite system built from scratch by students at Portland State University. It's Oregon's first satellite, and it's a 1U CubeSat that is providing flight heritage today for a modular, expandable, open source, and education-friendly Orsat bus, which has a global climate science and STEM outreach mission. So some very exciting payloads aboard today's Spaceflight Astra-1 mission.
And those payloads are bound to a sun-synchronous orbit, which is the target orbit for today's mission. That orbit has an inclination of 97.5 degrees, which is the angle between that orbit and the equator. So actually slightly retrograde, basically orbiting slightly towards the west, but mostly a polar orbit. And that altitude for that orbit is 525 kilometers, a pretty standard sun-synchronous orbit. And that mission will, of course, have the rocket fly south from Kodiak, Alaska. That drove the launch site choice for today's mission. Astra has also previously operated from Cape Canaveral in Florida for mid-inclination orbits, and will be doing so on future missions alongside the Kodiak, Alaska spaceport, which is the launch site for today's flight. I'm going to keep some questions coming here. Samurai is asking how the weather is looking today. We mentioned that weather is looking favorable, much better than yesterday. What are the weather items that the teams are looking at for today?
Right. So yesterday we were keeping an eye on triggered lightning, which is due to electrical fields in the atmosphere that can cause lightning to strike the vehicle as it moves at very high speed through the atmosphere. Today, the upper level winds are the item that we are tracking, but as of this time, they are not a concern for launch.
Yeah.
You got a gorgeous view there of the sunrise out in Kodiak. Just 22 minutes to go before launch, and the skies look beautiful. Should get some great views of the rocket as it ascends today. I have a question from Sebastian, who asked about, have the previous failed Astra missions affected today's launch? Of course, this is a return to flight mission. What have the teams learned and implemented for today?
Sure. I want to put in a quick plug for on Astra.com. You can read a very, very informative post from Andrew Griggs, our Senior Director of Mission Management, that talks about both our post-flight investigation procedure and what we learned. But if you joined us for the LV0008 mission back in February, we encountered two errors. One was a failure of the fairing separation system due to a mistake in the engineering drawing that caused the separation mechanisms to fire in the incorrect order. And we also had a software issue that prevented the upper stage from using its thrust vector control system. And for the first issue, that harnessing issue, that of course that error was corrected in the engineering drawing, and we've also implemented an end-of-the-line test to make sure that we can detect any similar type of issues before launch. And the software issue, the software team worked incredibly hard to uncover that it was due to a packet loss issue, and spent several weeks making the overall flight software for the vehicle more robust. And we are very glad to have worked with the FAA throughout our investigation process and have successfully returned to flight with LV0009 today.
This mission from Kodiak proceeds. The next three launches on the manifest are back at Cape Canaveral, actually, for the NASA Tropics mission, so looking forward to returning to the Space Coast as well. But today's mission from Kodiak looks like it'll be some awesome views. Looks like the weather is just clearing up perfectly. And look at that landscape. I mean, gotta love the Kodiak launch site. It's beautiful out there.
Absolutely. It's a
So,
gorgeous day for
Virginia
launch.
Swan says, please tell me how long the satellites last and what happens after do they come to the Earth, after they come down to the Earth. Okay, so talking about how long they last, it depends on whether the satellite has the propulsion system, and approximately what is the altitude of the satellite. Okay, so today the orbit which it is targeting is around 500 kilometers. So at that altitude, if you don't have any propulsion system, then the satellite last for around,
Yes, that's right. And just to
5 years
share a
or
little bit
so.
more about the red
So
team, you can
that's
send very
how,
small
would be
teeny
the
particles
life of
out
the
to the launch site
satellites,
with the rocket.
which will be deployed.
We are
And
very grateful for the work that they do,
um,
especially in
talking
cold
about
Kodiak.
what happens when they come down, well,
And so
they
we want to
just
give
get
a shout
burned
out
up in the
here to
atmosphere. While
Ryan Hirschfeld, our
the
safety
orbital
officer, Abby
speed
Bush,
of
our red team,
the
Phil Hudson, Robert Freeman,
um
Eric
and
Larson,
of the
and
satellite is like
our Mark
21,000 kilometers
225.
per
And
hour,
Steiny
which
is
means, or
our
you can say
IT
17,500 miles per hour, which is like
as
10
well,
times
which our
as
team
fast as
is
bullets.
very nimble and quick.
So it's
And
very,
they
very,
were
very
able to set up
fast.
the entire launch
So
site with a
yeah,
small number of folks, and we are very
that's
grateful
how that's why
for
when they enter the
the
atmosphere, they
limit
just burn
travel
up
during
because
the
of all
ongoing
those
COVID-19 pandemic
plasma buildup,
to
and
stay with us
literally the
and
plasma
help
acts as a knife which
of
actually
everyone
cuts through
involved in the mission.
the satellite, and
In addition
or
to the
whatever
red teams, of course, the
uh,
mission control team is
the
here in Alameda, and we can take a look
thing
at
which
it.
is
There is the
going to
launch
the
team. Karen, do you want to run us
atmosphere.
through the personnel that are on console today?
Sure. We have, starting from the top left, we'll have Lucas Hunley, who is our Flight Safety Officer, or FTS. Looks like Christopher Rossi, our GNC, is up from his seat for a moment. Joshua Green, our Vehicle Controller with the call sign of Tango. He's the one who is actually making, operating the system and allowing things to move through the vehicle. Chris May is our Command and Data Handling, or CDH. Jarrett Bullion is our Flight Activities Officer, FAO. And then we have Chris Hoffman, our Flight Director. As we move around the room, we have also a couple of folks in training as well as we continue to grow our team. And thank you very much to Mission Control here in Alameda that is operating our vehicle and keeping all of our operations safe today.
In addition to those personnel that are in the mission control room, there's also a couple backroom engineers who are at their own consoles to help support the engineering behind today's mission. But overall, a pretty small launch team at Astra compared to a lot of other launch providers, which is part of the design of the Astra launch system. It's interesting. Looking at some great close-up views of the rocket, you can see it nice and frosty due to the cold liquid oxygen that is loaded onto that first stage. Right below that, the ambient temperature kerosene, which is of course not as cold, although Alaska is pretty cold all on its own. And you can see the transporter erector, the strong back, right next to the rocket that is also venting its lines nominally. Everything looks good. That is all a perfectly normal part of the procedure, and the rocket looks to be in pretty good shape as the sun rises over Kodiak.
Exactly.
On that point, Ed is asking about the propellant that Astra does use on the rocket. So what propellant does the Astra Rocket 3 vehicle use?
Yeah, that's a wonderful question. We use a combination of liquid oxygen, which is that super cooled middle third of the vehicle that you can see, and then the fuel is RPX, which is essentially a form of kerosene. And we do use the same propellant on both the first and the second stage of the vehicle in order to help simplify our design and operations.
Have another question in chat talking about the Astra Store, which we introduced during yesterday's stream, store.astra.com, and a question that is only available in the U.S. right now. Is that correct?
Yes, it appears to be only available in the U.S., but part of it is we're taking the same approach to iteration that we do across the rest of our culture. And we only have a few products available right now. We're pretty limited, and we are looking to learn the kind of merchandise that folks are most interested in purchasing. So again, shop.astra.com is where you can buy cool items like the hoodie that Thomas is modeling today. And as a special note, for the first 2 weeks that the store is open, we are donating 100% of all of the profits to efforts supporting Ukraine, including UNICEF, the World Central Kitchen, and the International Committee of the Red Cross.
And my apologies, it was shop.astra.com. My apologies, not store. Shop.astra.com if you want to check that out.
That's great to hear. So we are at T minus 15 minutes. So we are entering into the terminal countdown.
At
Yeah.
T minus 15 minutes and counting. Again, everything is on track. This is the point yesterday where weather caused a delay, but today the weather is cooperating and no technical items being worked. So at 15 minutes and counting, the team has now entered terminal count for today's mission.
And yep, there is no hold. At 14:56 yesterday there was a hold, but today since the weather is great, so we are not having any hold, and things are
Again,
looking
today's
great.
mission, the goal is to deliver multiple customers to low Earth orbit. The mission is managed by Spaceflight Incorporated with 3 different payload customers on board, 2 of which are NearSpace Launch with the hosted S4 crossover payload, as well as the Portland State Aerospace Society's Orsat 0 CubeSat.
Okay, so yeah, and talking about the payloads, since the last flight of this rocket was basically resulted into a failure, so that's why today they will be actually deploying the payloads for the first time. So that is great, and the critical mission, part of this mission would be the fairing separation to this time, because that happened, that messed up last time, and they actually had to go through their engineering diagrams and change all those things. So we do look out for that.
And we have a handful of other containers that provide the vital ground support equipment and functionality that we need to operate the vehicle. So it's one of the most unique aspects of Astra's launch system is everything fits inside standard shipping and logistics. Excuse me, we're getting an updated UTC time, launch time.
Yeah. They're just setting the 16:22 UTC time.
We are setting our T0 time to the opening of the launch window, which is 9:22 a.m. Pacific and 16:22 UTC.
So guys, we are T minus 13 minutes from the launch. Everything is looking good, and there is no weather constraint or anything. So fingers crossed, and let's hope for a good flight. And there you go, the purge.
Well, one of the final milestones before we step into our launch operations is a static fire test of the integrated system that you saw the video of at the beginning of the broadcast if you joined us. And that is a full-on integrated test where we light the engines and verify that all of the systems are operating nominally. We also do a lot of thorough risk analysis of the system, look at the areas where we believe we need to mitigate risk. We fully vet our software as well. And this is all just part of our approach is to learn and test. One of the great things about our campus here in Alameda, California, is we do have engine testing facilities co-located right here next to the factory. So we can make changes to the engine and the stages and test them often the very same day. So we have a lot of different ways that we test and vet our system for safety before flight.
That's great.
There you go.
So, Flying the Bug, welcome to the stream, and you have likely covered this, but what's the max payload? So, talking about the maximum payload for this rocket, it is around 50 kilograms right now. It's like a teeny tiny rocket. It's like really small rocket, but they are planning to increase it to around 500 kgs to low Earth orbit. So, we'll see how that works out, but right now it's around 50 kilograms or so. Okay, so things are looking
You can see
good.
that the rocket has been propellant loaded. The frost on the outside of the tank indicating that, and the vehicle is going through its final checkouts and configurations for flight.
And that purge which you just saw, the liquid oxygen being dumped out of the stand from the beneath of the rocket or below the rocket, bottom part of the rocket.
Power systems active.
The flight helium stack.
That indicated that they have just almost they are almost done with the propellant loading as well as the top off. So you will see the securing happening very soon now.
VB1 first stage power.
VB1 first stage power active.
VB1 upper stage power.
VB1 upper stage power active.
VB1 turn on off PDBs.
VB1 turn on off PDBs active.
Water 1 water system.
Water 1 water system active.
Tango, at this time, please activate launch machine.
Launch machine.
Okay. Launch machine is being
Tango on countdown. Launch machine is active.
There you
Please
go.
toggle lock stopping.
Lock stopping set to true.
Clock stopping
This
secured.
takes us into step 144. This is the Astra pull for tank pressurization and launch. After this point, any system issue must be called as hold, hold, hold on countdown net. If there are no concerns for flight, call go. Otherwise, call no go. Red lead.
Red lead is go.
FTS.
FTS is go.
Delphin.
Dolphin go.
Ether.
Ether is go.
Odin.
Odin is go.
Inco.
Inco is go.
Ace.
Go.
Launcher.
Launcher is go.
Orbit.
Go.
Booster.
Booster is no-go until we finish lock stopping.
Ooh.
Okay, that means we're stopping.
Dude, that was something unexpected. It's okay, but because you know this they are just topping off the LOX liquid oxygen, which means they are just trying to fill it in. So I don't think so. It will you know, highlight in the countdown. It will matter in the countdown. So you just have to wait for that
Very well, then
topping.
boosters go.
There you go.
GNC.
GNC is go.
FAO.
FAO is go.
CDH.
CDH is go.
Tango.
Tango is go.
Safety.
Safety is go.
Flight is go. Tango and AV1 manage polling, toggle do only ground.
Do only ground polling set to true.
Tango, let me know when you're ready to load sequences.
Good to load.
Delphin, please provide.
Igniter 703 Victor 3.
So guys, we are go for the launch today. Everything is good. The vehicle is performing nominally. The tanks are pressurized and up to the flight level. And the weather is holding up and the range is also green. So things are looking great for the launch today. And let's hope we get a successful launch today. And let me just tell you, this rocket, the naughtiest rocket of all, which I love to call it, has failed like 4 times. So reliability is an issue with this rocket, but I'm pretty sure that they must have identified the issues and now they have corrected it. So as you know, the number of flights increases for this rocket, you will see a very drastic increase in the reliability. So guys, if you are just joining in, just sit back and relax and watch this launch, and hopefully you will see a successful and a beautiful launch today. So guys, just hit that like button and subscribe if you haven't for future launches also, because that's what I do. And if you want to support me, guys, please do that by becoming a member and or a Patreon, and super chats are always enabled for one-time funding. So with that, we are T minus 6 minutes. Everything is go for the launch.
GSC igniter system ready.
Tango, verify vehicle looks ready for launch.
And guys, if you are having some friends whom you would like to, you know, basically make them see a rocket launch, this would be a very good opportunity. We are just T minus 6 minutes or so. Do share this stream with your friends and let them know there's a rocket launch which is happening. Hello Kempin, how are you? I hope everything is fine in Ukraine. No holds. Yes, no holds for today. We are T minus 6 minutes and 3 seconds and coming in hot for the ignition. It can happen now. T minus 6 minutes. Whoa, that oxygen, that liquid oxygen coming onto the camera.
A few moments ago, the team completed the no-go poll. There was a brief no-go call from Booster, which is our first stage engineer, as we waited for propellant to complete topping. But we are all set. We also just got final range green as well.
Hey, you heard it, man.
So right now the teams are moving through the
Dude,
final steps
that
of the
looks
terminal
so cool.
countdown. Again, just over 5 minutes to go for launch, and everything appears on track. Let's take a look at the mission profile for today's ascent. Carolina?
All right, so starting from the bottom at T0, the first stage engines will light and we will have liftoff. A few seconds later, the vehicle will begin its pitch over maneuver. And at about 1 minute and 10 seconds, we will reach max Q, which is the point of maximum aerodynamic pressure on the vehicle. And the vehicle will continue to move through first stage flight up until 3 minutes, at which point we'll have main engine cutoff, or MECO. And then a few things happen in pretty quick succession. The fairing will separate, the stages will separate, and then at 3 minutes and 15 seconds after liftoff, the upper stage engine will ignite. And we will run for about 5.5 minutes before second engine cutoff, or SECO. And very shortly thereafter, we will have our payload deployment for the Spaceflight Astra-1 mission.
And we're just over 4 minutes away from the beginning of that ascent profile. Again, this is the launch attempt for the Spaceflight Incorporated Astra-1 mission on Astra's Rocket 3 vehicle, LV0009, from Kodiak Island, Alaska. That launch time is 9:22 a.m. Pacific Time, 16:22 UTC. And the 3 different customers managed by Spaceflight Incorporated on board headed to a sun-synchronous orbit. Inclined 97.5 degrees, altitude 525 kilometers, low Earth orbit. And everything is on track for launch right now. We're going to be listening into the countdown as we get closer to T0, and we'll keep you updated as that proceeds.
So guys, the mist is on there, and things are
Reminder,
looking
control room,
great.
if you require RF data once the vehicle leaves the pad, be prepared to switch over your Grafana pages.
Yes, Kempin, please, if you have some bunkers in there, please switch over, go in them, because that's
FSL,
not
flight
good.
on countdown, be
Oh,
prepared
I
to
hope
issue
you
option when
will be
rocket IIP
all
monitor
right,
passes
but
option enable gate
right now,
following
T minus 3 minutes, guys, things are looking good, and that mist, God, this thing looks so beautiful with that fog all around. I mean, I haven't seen this thing, purging so much of liquid oxygen.
3 minutes.
3 minutes and counting.
Like that, but let's see. There you go.
Reminder to all that any 3-word hold from here on out will be an immediate abort regardless of source.
That's great campaign, and there you go, T minus 2 minutes, guys. And that was a bottom purge. That means the liquid oxygen tanks have been secured now, finally. So 2 minutes and 30 seconds. So if you are just joining in, guys, this is an Astra
2.5
rocket
minutes
launch,
to go, all on track.
having 3 payloads. One of them will deploy, another one will not deploy, and the third one is not disclosed. So this is the thing. And yes, do look out for that fairing separation this time, because they literally made some changes in the engineering diagram, and we'll have to see how that has improved the fairing separation mechanism.
2 minutes.
T minus 2 minutes, guys. Whoa, I'm getting very excited, and look at those views, those hills, those mountains, whatever you want to call them. Just looks amazing. Everyone is waiting for that moment. Cheer, right?
And there you got the Astra team watching live from Alameda, California. Looking forward to today's launch, just over 90 seconds away.
So guys, hit that like button, subscribe if you are new, and
90 seconds.
just enjoy the launch.
Ace, at this time, start your PSD recordings and downrange ground station recordings.
Done.
We have people watching this from all over the world. Yes, the prayers are from the all over the world to
60
this rocket
seconds,
successful.
vehicles on internal control.
T minus 60
Less than
seconds,
60
guys.
seconds to go. The rocket has taken control of the countdown, and everything is on track for liftoff.
There you go.
You'll
So
have live telemetry on the bottom right hand of your
45.
screen, and you can track
First
the
stage
progress
lock tank
towards
coming
orbit
to
on the
pressure.
left.
Upper stage tanks at pre-liftoff. First stage fuel tank pressurizing.
minus 30 seconds, guys.
30 seconds.
Okay. This is becoming interesting. T minus 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10.
10. Water on. 8, 7, 6, 5, 4, 3.
First motion.
Vehicle has cleared the tower.
That was the smoothest liftoff
LV
of all the Astra
0009,
launches.
it's on its way to space. Our next objective is Max Q in just under a minute.
Gorgeous liftoff views from Kodiak, Alaska. T plus 25 seconds. Looking good.
Finally, as they say, the American broomstick is on its way to space. That is so cool. Finally, the launch is
T
looking
plus 45,
great.
still looking good.
I don't think so. We'll have some onboard camera views.
Kodiak, Alaska towards orbit.
Max Q is coming up. You'll see the camera's views. Okay, we
Now
do
you got
have
an onboard view of on the first stage looking down towards the engine section.
It's great.
And a beautiful contrail as the vehicle ascends towards space.
That little fire blob in the sky is so amazing to watch.
Vehicle is now through the area of maximum dynamic pressure, or max Q, the point of maximum stress on the vehicle. Everything looking good.
We have about 90 seconds remaining in the first stage portion of the flight.
Things are looking good. Okay, so the
Coming
rocket
up
is
will be
above
main engine
the
cutoff, or MECO, which is the shutdown of the
Wait,
5
you mean,
first stage engines prior to stage separation.
rocket is not at the bottom of the screen, but
you can see the
no,
plume from the first stage expanding
the,
as the rocket
upper
gets
part
higher in
of
the
the
atmosphere
screen.
with less atmospheric pressure.
yes, they have removed the telemetry for some reason, but I think everything is going as per the plan. We have reached the max Q already. The next event is the
T
MECO.
plus 2 minutes into the flight of LV0009.
Still got a great tracking shot from the launch site in Kodiak.
Okay, MECO should happen now in just few
Good
seconds.
tracking downrange.
Things are looking good. And look out for that fairing separation, guys. And
in just about 30 seconds, we have a string of milestones on quick succession. We'll have the first stage engines shut down, main engine cutoff, and then the fairing separation and stage separation and upper stage ignition steps will happen in very quick succession.
Safety can't confirm. Option received.
Option received.
so telemetry is a problem here, but everything else is looking good. MECO and
Vehicles left the gate.
fairing has
There's
separated.
fairing separation.
MECO,
Stage separation.
Stage
Stage separation
we have SEP.
and upper stage
ignition,
engine
dude.
ignition. Cheers coming from the Astra team as a significant portion of our flight milestones have been accomplished.
Finally.
We have about 5 minutes of second stage flight before our payloads are deployed.
Look.
And just a
Look at
great view
that.
of the Earth from space on that upper stage camera on your right. Still seeing the first stage camera looking up at the upper stage on the left. So cool camera views.
Wow. Yes, for some reason the telemetry has stuck, but the rocket is performing good. That's what we want to see, right? Things are looking great. That was a phenomenal separation. Finally did it, man. They finally did it. And let's just hope they are able to deploy it also, because this is the first time they will be deploying a satellite. So it will this stage will burn till 8 minutes or so. So like 4-minute burn time is still remaining on this upper stage.
Over
And
4 minutes into the flight, everything looking good so far. Upper stage is accelerating horizontally towards orbit.
Okay, there you go.
Needing to
The
achieve that horizontal velocity to
telemetry
stay in a
is
sun-synchronous
working
orbit, again
now.
aiming for an altitude of 525 kilometers today.
184 kilometers the altitude right now. Things are looking good. Still wait 302. Yes,
Looks like
it
now
is
we've got that
climbing.
telemetry updating on the bottom right hand of your screen. Over 300 kilometers in altitude right now. And a little under 4.5 kilometers per second of velocity. On the left, the launch team here at Alameda watching the vehicle closely. Everything looks to be operating nominally.
That is great.
All right, T plus 5 minutes and counting.
334 kilometers. Things are looking
Here's
good.
much of the Astra team in our factory here in Alameda that's gathered around our big screen jumbotron. As we enjoy the second stage portion of flight, we want to take a shout out to all of the team and all of the families and loved ones who have helped make today's launch possible.
Yay,
T plus 5.5 minutes, still looking good.
Yeah, view is indeed beautiful.
About 3 more minutes left in the burn of today's
Whoa,
flight.
just see
and
that.
another gorgeous onboard view of Earth.
Vehicle's
That-
now passing Hawaii.
Some sort of tornado or something, which we can see it from space. That is so cool if that's the case. Wow, see that. Hurricane or tornado, whatever it is, cyclone. That was such an amazing view.
T plus 6 minutes. We've crossed 400 kilometers in altitude. We have about 2.5 minutes remaining in the second stage flight.
You see that engine bell glowing red hot as it burns.
Still climbing.
That is expected, of course.
And the velocity is still increasing.
And a live
That's
telemetry
what
view showing the trajectory south from Kodiak, Alaska, again towards that sun-synchronous orbit, right down the middle so far.
if it's in Atlantic, then it's hurricane.
Over 6.5 minutes in the flight.
Well,
now,
it is
coming up
going to
350
the
kilometers
at the
altitude,
southern
over 5
part
kilometers per second.
of the US. So I think that is what it is saying. So maybe it is hurricane or something like that. So cool, like from a rocket launch, which is actually launching a satellite, you can see some hurricane from space. No, they are not over the Arctic. They are going to the southern direction, basically.
7 minutes in the flight, still looking good.
Still climbing, and still the velocity is increasing. That's what we want to
You can
hear.
see just the faint outline of Earth as sunrise rose over the launch site not long before liftoff. Over 6 kilometers per second of velocity now and coming up on 500 kilometers altitude.
6 kilometers per second. Orbital velocity is around 7.5
Less than a minute to go until SECO, or second engine cutoff.
kilometers per second or so. The altitude has already reached 511 kilometers.
And shortly after SECO, second engine cutoff, we will have the deployment of some of the payloads aboard today's mission of Spaceflight Astra-1. There is one payload that will remain attached to the upper stage and will begin its mission after SECO as well.
7.1 kilometers per second reached, and 521 kilometer is the altitude.
Second engine cutoff milestone next.
Yes, it's coming up very, very soon now. .525 kilometers.
SECO.
And we have SECO.
There you have it, second engine cutoff, SECO confirmed.
Dude, they are so accurate with the altitude thing, but velocity 7.5
We'll be looking
kilometer.
for the callouts for the payloads that
Let's
are
see.
being deployed next.
We'll have to wait and see. I think they have reached the orbit, but we'll still have to wait and see. Waiting for the payload to deploy. You know, the people are not happy, like not cheering when it has reached the orbit, because I can see the velocity is like a bit off Should be around 8 kilometers per second. May not have reached the orbit. We'll have to wait and see. I hope that is not the case. Just my calculations which are wrong. Because you are not seeing the cheering and all when the orbit is achieved. I highly doubt, because we can see the velocities also. The 7.5 kilometers is not what you want.
There you have the trajectory right down the middle for today's
hope,
ascent,
though.
and we're standing by to
We
hear a
shall
word
not
of
speculate.
payload separation.
Let's hope my calculations are wrong. And the trajectory also seems a bit off, I must say that. Dude, if they are, you know, let's hope it is successful. I don't want to say anything. Although we are not receiving any other updated telemetry right now, like the velocity should be increasing or decreasing, I don't know, and we are not even seeing the live views of the second stage. And this is not, the silence is not what you want to hear, what you want to see in a mission control room when the SECO has already happened. And now they actually can't do anything if it has not achieved the orbit.
We're at T plus 11 minutes after liftoff.
Actually, the payloads should have already deployed by now.
And second stage portions of flight. Reaching our...
If you see the timeline, you can see that the payload should have already been deployed.
Confirmation that the payloads have been deployed.
Okay. Okay, guys, people who are just joining in, let me just tell you that they have had a successful liftoff. Everything went as per the plan, and they had a successful SECO also. So things are looking great on that front. But if you see the telemetry, the velocity is a bit off than the orbital velocity which you want. It's like 7.6 kilometers a second.
Pad in Kodiak, Alaska.
So, and people are not cheering, so we'll have to wait and see if it has even achieved an orbit or not. Okay, still waiting. Okay. Now it would be very interesting to see if they have really messed up now, and it would be very interesting to see what was the thing which went wrong this time. I just don't want to say that, but it looks like the things are not looking great right now. And talking about, yes, mechanics whale, I try to do that. I don't speak over mission control, right? I just speak over those commentators sometimes, and I don't do that a lot. Sometimes that happens because I'm speaking something but if there is
plus 13 minutes,
some important milestones or updates from them, I just stop talking. They're still waiting for the payload deployment to happen.
Otherwise, it appears all other mission events were nominal during the LV0009 flight this morning.
Okay, that is good to hear. If everything was nominal, all other events, so they might have reached the orbit. That's not good. See, this is the first mission in which they were actually trying to deploy some satellites. In the other mission, the Ilana 41 mission, which was unsuccessful, they were supposed to deploy the satellites, but that did not happen. And now this is the first time they were trying to deploy a satellite in space. So deployment of a satellite itself is a challenge for them. That's a critical milestone because they haven't done that in space yet. But still waiting for things to happen. Yes, everything nominal, as they say, but let's see. Because if the orbit must have reached, then we should have heard some cheering or something like that. I may be speculating right now, but let's see. Let's hope. Let's hope, guys. Let fingers crossed and wait for the official update. Talks. Well, when you have a public rocket company, highly whosoever is planning to make a rocket company in future, please guys, don't make your rocket company public very soon, until unless you have a very.
Thanks for standing by with us. We are still awaiting confirmation that our payload deployment has been successful. About 6 minutes ago, we completed the flight profile of LV0009, ending in a successful second engine cutoff at the mission altitude of 525 kilometers.
Okay, actually they reach the altitude of 525 kilometer. I am not so sure about the speed though. 7.6 kilometers per second is like very at the very, at the borderline. I'm not so sure. I have to do the exact calculations to get the velocity, but seems a bit short. We'll have to wait and see though. Yeah, I was saying that please don't make your company public until unless you have a very good reliability record with your rockets. You're planning to make a rocket company in future. Yes, the stocks have fallen already. They might have reached the orbit.
Looking again there at our trajectory for today's flight.
Because see, the payload separation was scheduled for just 10 seconds after the second engine cutoff, and that did not happen. Maybe that was the reason why they didn't they were not sharing when the SECO happened. Maybe they have reached the orbit, but not the satellites have not been deployed.
On that final step of the ascent profile, want to make sure that is confirmed before we report anything, so just standing by for that. But the early ascent looked picture perfect, so just stand by for one more confirmation.
Now they have like two things specially for this satellite. Basically, the satellite itself has some power system and all those things, right? So we'll have to wait and see how, if we are getting a signal from the satellite itself, or what is the case with the second stage itself. We'll have to wait and see. I don't want to say this, but the telemetry was a bit off this time, and we may not get the final telemetry indicating the speeds and the altitude. So never know whether they have reached the orbit or not. Have to wait and see. Like if they are still waiting for the separation to occur, then I think they have reached the orbit, but not yet separated the satellite. But still waiting, still waiting. The Rocket Lab is much stable, successful flight every time. Yes, indeed. I am very amazed by the Rocket Lab itself, because they only had like 2 failures till now, and in the developmental flights also they did not had a failure. They had 2 failures after they were launching, reliably for a very long time, and then they had some failure. It's a very pretty, what should I say, impressive record from them. But for Astra, man, this company is kind of hanging now. I must say that. They had out of 6 launches, I guess. I 4 of them are unsuccessful. 2 were successful, and this is the 5th unsuccessful mission. If that happens, I don't want to say that, but still, it's been funded by Department of Defense, so we'll have to. I don't know what's the liability thing. For this company, like how much liability they can um, take for the rockets, how much can they um, you know survive, because they have already been in public now, the company's public. Okay, we heard something from the mission control, but that was not of any value.
And thank you so much for joining us for this morning's LV0009 launch broadcast. We're at T plus about 20 minutes from the launch. About 10 minutes ago, LV0009 successfully made it to orbit after a nominal first stage and second stage flight. We have not yet received any information about the payloads being successfully deployed. The vehicle was far downrange of our telemetry dish, which is as expected, and so it may be a little while before we have an update on that, and we will provide that update on Twitter as soon as we have it. But for now, we're going to wrap up today's broadcast after a successful ride to orbit for Astra's LV0009.
Okay, that
yeah, just stay tuned for that final confirmation step. That'll be all over Astra's social media channels as well as by NASA Spaceflight. But thank you so much for tuning to our live launch coverage for a picture-perfect launch of the rocket. Carolina, thank you so much for joining me for today's launch. It was a pleasure.
Thank you as always, Thomas.
Thank you all so much for watching, and thank you to Astra for once again partnering with NASA Spaceflight for today's launch coverage. Stay tuned for future launch coverage and other spaceflight news coverage here on NASA Spaceflight. And until the next time, this is Thomas Burkhart, News Director for NASA Spaceflight, signing off. We'll see you next time.
Okay, so guys, wait a second, okay? We'll do something, don't worry. A sec. Yeah, so as I was saying, that doubt is off now. That means they made it to the orbit. So that was great. But the separation thingy, they have not yet confirmed. So let me just tell you this thing now, that this happens in the rocket industries, that the separation would have happened successfully, but they might not have received the signal yet because, you know, as she said, it was well below downrange, so maybe it was not in the range. But when you know, the Earth rotates and the satellites also orbits around the Earth, you might see a signal after some time. So if that happens, then obviously we'll see the confirmation on their Twitter. So still, I can't say if it is successful or not. I mean, obviously the flight was successful. It reached the orbit successfully, but the separation, but as I said, this was the first time they were testing this separation in space. So we'll have to wait and see. Although this has happened in the past in other rocket launches, that the separation has happened successfully, but still the confirmation did not happen at that point of time due to some communication issues or something like that. But after some time, they were able to communicate with the satellite. And that is the case, then we'll have to wait and see. Or maybe satellite is just safe, and the separation mechanism may not have reported it properly. Again, the packet loss thing, but I'm pretty sure that is not what is happening. I mean, if really the reason is same for unsuccessful flight like the previous one and this one, that is not a good thing. But that does not happen in the rocket industry. So yeah, sounds like they just don't have the ground coverage to confirm the payload deploy. Yes, it does sound like that. Yep, right now it does sound like that. Although still, guys, it's hard. The space is always hard, and we are just with SpaceX in place, and Elon Musk is always the alien who is trying to reach back to its home planet. We have seen some amazing things happening with the rockets, and with the reliable rocket launches that his company is doing is just incredible. I don't remember when was the last failure of SpaceX. I mean, if we just exclude the Starship ones, but Falcon 9 has been flying reliably for quite a long time. Okay, so yeah, so we do have some thing in here. Let's see what updates do we have. No updates from Astra. Fine. Flight complete, but the company has yet had deployment confirmation and reached orbit, but still they're waiting the payload deployment. And guys, those who have a let's just see the stocks, right? Now, yeah, this is not good. I mean, if the flight is successful, now what would happen? Tell me. what would happen then? I'm not so expert in the flight stocks basically, so I can't say much, but yeah, you know. And the Artemis guys, this is happening, dude. We are going to the moon. The March 17th, mark your calendars. We will be having a rollout of the SLS rocket. Although this rocket is like $4 billion in cost, but it's good. It's good, right? Okay. Let me just we can do a quick hot fire was said over the comms loop. Yeah, everything is perfectly fine. Quick hot fire, what does that mean? Are they planning to reignite the engines or what? So that it reaches the intended place where they can get the proper telemetry from the rocket much faster. Yeah. Okay, let's just see whether if we have any updates from them. We had a nominal first and upper stage flights and are awaiting the payload deployment confirmation. Stay tuned for updates. So everything was nominal, so they did indeed reach the orbit without any problem. The problem occurred with the payloads, and not so sure I mean how many payloads were being deployed. Like we know that one was not being deployed and other one was supposed to deploy, and there was also a third one which they haven't disclosed yet. I mean, what was the satellite or a thing which is not to be deployed, so still waiting for those things. Hey, there you go. Welcome to the vehicle assembly building, crawler transporter 2. Guys, this is actually happening. The SLS is has been completely made, and Artemis 1 mission is happening. We'll see the rollout from the vehicle assembly building very soon now on March 17, and in June the Artemis 1 mission is scheduled. Although guys, again, that moon sorry, that moon rocket cost around $4 billion, so not so sustainable, but we have Starship in place. So oh dude, okay, coverage in here. Okay, we will be having a rollout which will be covered live, so that is interesting. If it is being covered live, so I'll be there with you. I'll be there with you for sure. Cover it live for you guys. Okay. Cool. Still, yeah. So at the end of the day, guys, we had a successful flight. As you can see, the successful flight of the first stage, the liftoff was successful. The second stage burned as per the plan, but still waiting for the confirmation of the payload deployment, and we'll get to see and we get to know about that in the nick of time as they confirm. Actually, the payload deployment was supposed to happen just 10 seconds after the liftoff, so yeah, that did not happen. Okay. So if they reach the orbit but were not able to deploy the satellite, will this be considered as a successful flight or a failure? Yes, Thomas Gomez, still waiting for the deployment confirmation. Thank you so much, Simon. It's great. 10 seconds after liftoff. Yes. Not after liftoff, sorry. 10 seconds after, if I said that, 10 seconds after the second engine cutoff. Pico. If it did happen like after 10 seconds only, After the lift of the payload did separate after just 10 seconds only from the liftoff. Well, that satellite had a pretty hard ride to space. Cell. Okay. Okay, what will happen when if they have the mission is successful? That I don't know how the things. Okay, so we have like pretty good updates on some things in here. Like obviously this rollout is happening very soon on March 17th, and on March 18th, interestingly, I'm not so surprised though, but people might be surprised by that we are having a Soyuz launch from Russia to International Space Station. That is the MS-21 launch, which will carry some astronauts to International Space Station. To be precise, cosmonauts although. So yeah, and there is no US astronaut in that flight, but yes, amidst all these things, we are having a rocket launch from Russia, and I'll be covering that. Science is always my preferred thing, and it is at the topmost of all the things. So yeah. Okay. The next mission, the next thing is that only the rollout. I must be there on 17th of March for the rollout, as well as on 18th of March for the Soyuz launch. So guys, I think that is pretty much about it. If you have anything else, you can write in the comments, write in the chat, and if you haven't already liked the stream, please do that. It would really mean a lot. And if you haven't subscribed already, that would also mean a lot if you can do that, because rollout, the launches, the other space events, and some occasional space videos are up on the channel, so you can just go out and watch them. If you want to support me, please do that. I really need your support. By becoming a member and or a Patreon. So okay, so reiterating the fact that, guys, we had a successful liftoff from the launch pad. I must say that the launch was very smoothest of all the Astra launches that I have seen, and everything was going as per the plan. The fairing separation happened, there was no problem with that. The second stage ignition happened, and yeah, there was no problem with that too. And it successfully reached the orbit. And obviously, if you were seeing the orbit, the apogee was kind of close to 525 kilometers, although it quickly started decreasing. The last awaited, or you can say the last thing which we saw, was at 524 kilometers. Although we'll have to run some numbers if there was some issue with getting the orbit circularized, because you can get to the orbit but not the intended orbit. So we'll have to wait and see for the official word from the Astra. So thank you all for joining in, guys, and we'll meet you soon for the Artemis 1 mission, the SLS rollout. That would be a pretty good thing to watch. Finally, we'll be seeing a moon rocket which will enable humans to go back to the moon. Oh man, what world we are living in. That is good. At least that is a good news to hear for all space fan, as well as for all the general public. Okay, so I hope everyone is safe and sound in their homes, especially in Ukraine. My prayers go out for you guys. And until then, this is Priyanshu Royla. You just saw Rocket Gyan. Stay safe, stay healthy, and bye-bye.